Hi everyone. Today we're going to study some summation formulas. Let's begin with the first summation. We have the summation of A times R raised to K, where K here equals 0 up to N. There's one condition that R is not equal to 0. And the closed form will be like this. In here, R should not be equal to 1. Next, summation of K, where K equals 1 up to N. The value is N times the quantity N plus 1, all over 2. Next, summation of K square, where K equals 1 up to N. The value is N times the quantity N plus 1 times the quantity 2N plus 1, all over 6. Summation of K cube, where K equals 1 up to N. This is the closed form. This is similar to our formula in here, except there is power 2 in this closed form. Next is summation of x raised to k, where k equals 0 up to infinity, given that the absolute value of x is less than 1. And the form is 1 over 1 minus x. Summation of k times x that is raised to k minus 1, where k equals 1 up to infinity. In here, the absolute value of x is less than 1. And the value is 1 over the quantity 1 minus x is raised to power 2. Let us see some examples. Example 1, find the summation of k square, where k equals 50 up to 100. Take note that summation of k square, where k equals 1 up to 100, is equal to the two summations here. The first is summation of k square, where k equals 1 up to 49, plus summation of k square, where k equals 50 up to 100. In our problem here, it refers to this summation. With this equation, if we want to solve for this summation, we're going to transpose this first summation to the left side. So we will have like this. Summation of k square, where k equals 50 up to 100, and that is our problem, is equal now to summation of k square, where k equals 1 up to 100, minus summation of k square, where k equals 1 up to 49. We're going to use one of our formula in our list a while ago, and that is summation of k square, where k equals 1 up to n, and this is the value. In our first summation, the n is 100. So we will have now this 100 times the quantity 100 plus 1 times 2 times 100 plus 1, all over 6, minus the second summation. Our n here is 49. So we write here 49 times the quantity 49 plus 1 times the quantity 2 times 49 plus 1, all over 6. We simplify the numerators respectively into 100 times 101 times 201, and this is all over 6, minus the second numerator will be 49 times 50 times 99, all over 6. Simplifying the fractions, we will have now this first fraction equivalent to 338,350 minus the second fraction is equal to 40,425. And the difference is 297,925. This is the final answer. Example 2. Find the value of summation of the quantity k times k minus 1 times k plus 1, where k equals 1 up to 10. We copy our problem down here, and the first thing that we will do is to simplify our function. Let's begin by multiplying this k minus 1 times k plus 1. So we will have this k squared minus 1. And then this k outside, we will distribute to each of the terms inside the grouping symbol. We have now this summation of k cubed minus k, where k equals 1 up to 10. From here, we're going to distribute the summation notation into k cubed and then with the minus k respectively. So we will have like this: summation of k cubed, where k equals 1 up to 10, minus summation of k, where k equals 1 up to 10. In our list of formulas a while ago, we have like this. We're going to substitute the corresponding values respectively. Then let us evaluate respectively. We have now this 10 times 11 over 2, and this is raised to power 2, minus 10 times 11 over 2. We simplify each into 55 squared minus 55. This 55 squared is equivalent to 3025 minus 55. The difference is now 2970. This is the final answer. I hope you learned something from this video. See you again next time.